Okay, so it says a data set includes two outliers, one at each end. If both outliers are removed, which of the following is a possible result? Both the mean and median remain unchanged. Well, the mean and median both lie in the middle. So if I take one thing from the very end that's far away and one thing from the other end that's very far away, the middle should still be the same. So I'm going to say that this is probably the answer. Both the mean and standard deviation increase. No, if I'm taking stuff away, they're definitely not going to increase. Both the median and standard deviation remain unchanged. Well, no, my standard deviation would change because now I'm changing the spread of my data. So that's not true. So anything with standard deviation isn't true. So that's not true, that's not true. So, yep, back to the beginning. So both the mean and the median remain unchanged because they're both in the middle. An AP statistics teacher grades using z-scores. On the second major exam of the marking period, a student receives a grade of a z-score of negative 1.3. What is the correct interpretation of this grade? Okay, well, I know that negative 1.3 means that that student scored 1.3 standard deviations below the average in the class. So that's what I'm looking for. The student scored 1.3 standard deviations lower on the second exam than the class average on the first exam. First exam? It doesn't say anything in my question about a first exam. So that's not it because I don't know anything about my first exam. The student scored 1.3 standard deviations lower on the second exam than the class average on the second exam. I'm going to say that one's probably it, but I'm going to keep reading just to make sure. The student's grade went down 1.3 points more than the average grade. Nope. And first exam again. What does that mean? This one says first, so that's not it. This one says first exam, so that's not it. So I know that I've got my correct answer. Okay, so it says these dot plots for randomly selected male and female students at a particular high school show the number of times per week they eat at fast food restaurants. Which of the following is a true statement? The standard deviations are the same. I don't know about that. Combining the male and female times into one set of student times will increase the range to the sum of the individual ranges. No, their ranges are the same. 5 minus 0 is 5, and 5 minus 0 is 5, and if I put all those together, it's still going to be 5. So I definitely know it's not this one. The difference in their means is less than the difference in their medians. I don't know, I'm going to come back to it. The ranges are both 7. No, we just said the ranges were 5. One distribution is roughly symmetric and the other one's skewed left. Well, I know the female one is not skewed left. It looks like it's skewed right to me because it has a right tail. So it's definitely not this one. All right, so I've got between these two. So I actually plug it into my calculator, into a list. But another way I could do it is if I say, okay, since this male looks about symmetric, approximately, so my mean and my median are probably both here at 3. But then on this one is right skewed. So my median is probably here. And I know that my mean is going to get pulled this direction. So I bet it's going to be somewhere around here-ish. So if I look at that, I already can tell that looking at the distance, so from, if I say for the median if the median for the male is 3 and the median for the female is 1, I know that 3 minus 1 gives me 2. But if I say that the mean for the male is 3 and the mean for the female is 2, then I know that 3 minus 2 equals 1. So the difference in their means is less than the difference in their medians. And that is because the female is skewed to the right. So I'm going to go with that answer. Which of the following statements is incorrect? In histograms, relative areas correspond to relative frequencies. That's true because relative areas and relative frequencies deal with percents. So that's a true statement, so I know it's not this one. In histograms, frequencies can be determined from relative heights. No. We're talking about percent, and we're talking about like numbers of how many times that happened. So that's not gonna help us. Like, I'm not gonna be able to work backwards to find my numbers of frequencies from their relative heights. So that's incorrect, but I just want to go through the rest of them to make sure. Sets with different distribution shapes can have identical box plots. That's true, so that's not it. Box plot, dot plot, stem plots, and histograms can all show skewness. That's true, so not that one. Both dot plots and stem plots can show symmetry, gaps, clusters, and outliers. Also true. So I know that it was the one that I was talking about from before. Okay, so the easiest way to do this problem is to plug your data from the stem and leaf plots into your a list onto your calculator. So what I did was I put A into list 1 and B into list 2 on my TI-84. If you're using an Inspire, you can just put them into your list and spreadsheet in column A and column B. Now, they don't tell you what this represents, but what this plot is actually telling you is that A there, the first number would be 104, the next number would be 105, and then the next one would be 111, 116, 118. So I hope that helps you figure out what the numbers are. Now, after I plug it into my calculator and I run my one variable statistics, okay, so here is the information that I got from my one variable statistics from my calculator. So I wrote all of the information out. So the first thing I have put is X bar, the mean, and then the standard deviation, the minimum, the maximum, Q1, the median, and Q3. So it says distributions, we're looking for the incorrect answer. So it says distributions have the same mean. Well, right there looking at that, I know that that's not true. So that's probably our answer. Distributions have the same range. They do have the same range when you subtract. It's just that B is like moved up 10 more points than A was. The interquartile range is the same, and that again is true. Distributions have the same standard deviation, and that is true, which would be your SX. Distributions have the same variance. Well, if they have the same standard deviation, then they also have the same variance. So A, the means are the same, is not true, because we can see right here that the X bars are different.